So it's 11 o'clock. Welcome, everyone. It's always good to start on time, otherwise we reward the people being late. And let's start now together, because we have a lot of interesting things to tell everyone. I think there'll be some people maybe dripping into the meeting still in the next few minutes, but I'm going to start off with a brief introduction on the program. So again, welcome. And we're excited to share with you today the story from the RePlanIT project, showcasing impact measurement research. This is what we're going to be talking about today. And we have 1 hour till 12 o'clock. We have sufficient room for questions. So we reserve 10 minutes in the end also for to have a nice discussion with you all. So save your questions for then. My next slide, I would like to say again, welcome. The webinar is being recorded so that we can later on share it on the YouTube channel of the NCDD. And also the presentation will be shared later on our website. So for all the people that could not make it today, they are welcome to join. I say welcome to join and let people in. Welcome, everyone. And people can later on see it. So for during the webinar, I would request everyone to let their cameras and their microphones off so we can all see the presentation well. And then in the end, when you have a question, you can raise your hand and turn on your mic and your camera if you like to ask your question. So that's having said that, I will take you all briefly through the program. And so what we're going to be talking about today is first this brief introduction by me. I will also shortly introduce the NCDD. Already familiar to some of you, but maybe not to all of you. And then Menno van Dijk will give a brief introduction to the RePlanIT project. Anelia Kurteva from TU Delft will continue with a story or a presentation on her research on product passports and ontology. And Menno van Leeuwen will then take over with his part on true price of data. So this is content-wise our program, and then we, of course, saved room for discussion. So for now, just to briefly start off with a short introduction to the NCDD. In Dutch is Nationale Coalitie Duurzame Digitalisering, National Coalition Sustainable Digitalization. And what we work on is very nicely illustrated by this little graphic, this little house of sustainable digitalization. Actually, in the roof in Dutch, for those who read Dutch, it formulates our overarching overall goal, which is reducing the environmental impact of and by digitalization. So we work as a coalition in different work groups together with our members. With around 35 active members right now and more coming in almost every week. So it's an exciting time for us. It's a very relevant time, I think, also to work on this topic. And we work on it by the different pillars that you can see illustrated in this house, which is on the left, technical innovations. So think, for example, on AI, there's lots of new tech innovations. How do we make sure this happens in a sustainable way? This is one of our angles of focus. Then in the middle, you can see making IT within organizations more sustainable. So this webinar very nicely connects to that, looking, for example, at the hardware. But also think, for example, on data and data storage. This is one other, data centers. This is one other very... Also coming back today, actually, and another very important topic to take into consideration, into scope. And then on the right, you can see the third pillar, which is more sustainable by IT. And this is in certain occasions, of course, IT can also help to make processes more efficient and more sustainable. So this is different angles we work on as within the coalition. And all this stools on our preconditions, which is, for example, knowledge sharing through communications and also working on a legal framework that supports this transition. So this on the Nationale Coalitie Duurzame Digitalisering, NCDD. And I would like to then pass the word to Menno van Dijk, who is going to give us an introduction on the RePlanIT project. Enjoy.
Yeah, thanks. I'm sharing my screen. And so we're gonna explain today things that stem from a project. And project is called RePlanIT. And this was a project which is aimed at extending the life of business IT hardware. And why do we want to extend the life of business IT hardware? Because that reduces e-waste, it saves raw materials, and it's a very effective circular strategy, and of course also a very effective economic strategy. So what we did is we started up in a consortium with a lot of partners. Partners are on the slide. And we built and tested actual prototypes. So we built a tool that would help to achieve the lifetime extension of ICT hardware. We included TU Delft's data science and behavior science research to make it really science-based. And we made a prototype, one for laptops and one for servers. So how do these prototypes work? Starts with a product passport. And this is not a normal product passport. This is a dynamic product passport, which includes usage data of the hardware. So that means for servers, you can store information on memory use or and energy use at every 10 minutes or even higher frequencies. And based on this data, we built two front-end applications. A circular resource planner, which offers scenarios for optimizing this circularity of your hardware, decision support tool, and a circular resource configurator, which helps asset owners to keep an overview of their entire fleet. And als dat bij jullie zou dat heel fijn.
Menno, I think you're muted.
Menno is muted. I'm trying to unmute. I'm trying to mute the other person. There's a little background noise. Please, for everyone, please put your microphone on mute, because otherwise we can hear things on the background.
We can keep the camera off if they're not speaking. So I was saying, in the next part of this presentation, Anelia Kurteva will share her research on the dynamic product passports, which were developed for this application, for the RePlanIT application. And after that, Menno van Leeuwen will tell us about a new venture which was started by participants from the RePlanIT project, and is aimed on monetizing, but also spreading the benefits from that we found in the findings from RePlanIT. So both are very strongly related to this project. The project is almost at the end, but that's why we can share the actual results today. And I can now would like to give the word to Anelia.
Okay. Hi, everyone. Thank you, Menno, for the introduction. So let me just share my screen. I hope you can see the slides now. So I'll basically give you a quick overview of what has been happening on the technical side on the RePlanIT and how we made everything possible in terms of connecting different components and making the system work. So first, a bit of just introduction to what technologies we're using in the project. We're focusing on utilizing semantic web technologies, namely ontologies and knowledge graphs, which are known to support data sharing and FAIR data standards. So FAIR stands for findable, accessible, interpretable, and reusable. We also use ontologies to make a standard vocabulary of all the data that we want to store in the product passports. And to make everything a bit more dynamic and to utilize it in our system, we also resort to machine learning, and I will later on share some insights that we got from our models that we run. So quickly, for those of you who are not aware of what is an ontology or what is a knowledge graph, it's basically a way to represent data that's a bit different from traditional databases. In knowledge graph format, we have relationships between data that we specify. For example, here we can say that Da Vinci is a painter and he painted Mona Lisa. So this is called resource description framework or a triple format, and it's much more flexible than traditional databases when it comes to storing data. And particularly for our use case, it's quite useful, as I will share in the next slides, because it really allows to build context around the data and derive new insights. So now to the RePlanIT project and why exactly we wanted to build digital product passports in a fair way with ontologies and knowledge graphs. Our main goal was to interconnect the materials, ICT, and circular economy strategies domain, because currently they're a bit disconnected. There's a lot of knowledge silos, and we need infrastructures of data that help share data more easily and make it available for different uses within organizations, between organizations, and so on. So our goal was to make the product passports fair. Why? We wanted to derive knowledge from the data, not just to have the data in a file somewhere that can be used. We wanted also to understand the data and the different connections between it to derive new knowledge. With the use of ontologies and knowledge graphs, we support data traceability because we have different relationships, and this help on the technological side with traceability and transparency. And we also, within the project, wanted to support both human and machine-driven decision-making. So on the human side, we focus on ICT procurement in organizations, more specifically of laptops. And on the machine side, we focus on predictive maintenance, so utilizing the product passports to predict in the future when a device can fail, so we can take appropriate action earlier on and prevent that failure. How we started the research, we looked at the state of the art. We basically analyzed ontologies that exist for the materials domain. For ICT equipment, we focus more specifically on laptops and data servers, and for the circular economy. And we combined everything in this systematic survey that we published. Actually, it was accepted last month, so you can already go and check in more detail all the scientific basis for our work, so to say. And what we did in this paper was also to derive visual representation, so to say, or a model of what we think digital product passport of an ICT device should comprise of, so different data. And we wanted to store, of course, historical data on different levels. So for a laptop, for example, we also wanted to store data for each component of the laptop. And we know laptops have many components. For hard drives, we have cameras, keyboards. So we want to represent and store all this data in our product passport. For each component, we also want to record different physical properties that it has, such as the weight, the age, the memory, if it's a hard drive, also warranty, which is quite important in decision-making later on. We also focus on different sustainability properties of different components and devices, such as energy consumption, energy efficiency, CO2 footprint, and of course, material properties. So we wanted also to store different materials that go into the manufacturing of a device. And coming to the more sustainability part, we thought that it might be good for traceability to also represent different circular strategies that are applied to a device through its lifetime, so we can monitor everything and really have detailed and specific product passports. So now to one of the main contributions, so to say, in the RePlanIT project, our ontology for product passports of ICT. As I said, we focus on laptops and data servers as our main use cases, and we build this ontology that can be used as a standard data model for representing data that needs to go into the product passports of ICT devices. Here, just a quick overview of a visual overview, so to say, of what is happening in our data model. So we focus here, you can see on ICT device as as a main use case, and we represented different support for it, different hardware components, as I said, different circular strategies, different materials that go into the manufacturing, also more specific information such as the brand of the let's say the laptop that we want to create a product passport for. For provenance, we also included different agents in terms of organizations, people, and also software that interact with this device. And for example, if a circular strategy is applied, we want to record information about who is applying this circular strategy, how long it will take, what is the location, and so on. So we can really use our data model to do this in detail. Here a bit more statistics about the ontology that we created, almost 300 classes, and it's a quite big ontology, so to say. And you can actually go on the link here that I shared and have a look in detail in all of the different concepts that we included. Here is also another visual of the ontology. So as I said, yeah, for hardware components of laptops, we really go into details. We model batteries, different chips, cameras, capacitors, chases, chipsets, graphic cards. So for each one of these components, you can include also the material composition if you have information on it, and the lifetime and sustainability of the device. So another visual here, what I wanted to share is, how different hardware components are connected to an ICT device. And we say that an ICT device has a component, it's a hardware component, and then we can, of course, go into more detail and for each one of these components add data. Because we also focus on machine learning, as I'll share later on, we also looked into sensor data that's streamed from the devices. So we modeled different types of sensors from laptops, such as fingerprint sensors, electrical current sensors, pressure sensors, and so on, because this data can be quite useful later on to detect changes in the performance of a device. Another visual here, more on the material side of things. So we say that an ICT device, such as a laptop, let's say, has specific material composition. And here we went to quite a lot of detail, and we focused on modeling different types of materials, such as polymers, metals, nanomaterials, composites, ceramics, glasses, and of course, different types of these materials. This is just to show that with our data model, you can really specify how much of each material goes into your laptop and its components. And with regards to the materials, we also represent the notion of material criticality. We also have a bit of classification here, and we connect this to sustainability indicators that we have represented. And here, yes, are indicators. So these indicators are used to evaluate the sustainability of an ICT device through its lifetime, and it helps later on with ICT procurement to make more sustainable decisions about what laptops to procure for your organization. So in terms of indicators, we focus on economical indicators such as the cost of a circular activity, collection rate for devices, components, materials, current cost of the device, the purchase cost, which can be different. Of course, delivery time, which is quite important. Then we also have functional indicators that, let's say, more technical people are quite interested in when procuring laptops. So these include, let's say, the pixels of the camera, the screen size, the device age, battery capacity, and there are many more, but here, just for visual purposes, I put some of them. And of course, sustainability indicators that help evaluate the sustainability of the device. So what we represented or stored in our data model, so the product circularity, the amount of greenhouse emissions, the energy consumption, the overall environmental impact. We also have the waste, the material weight, material criticality, and also some end-of-life products during remanufacturing or other circular strategies. And as I said earlier on, we also wanted to capture provenance of all data and also be transparent of what is happening and who is doing what with your ICT device. So we modeled different agents, and we represented the organization that this agent is from, email address, telephone number, which one might use to contact the organization if there's some issue with their refurbishment, let's say, of the device. And yeah, for each activity, let's say refurbishment, we also wanted to capture information about the location where this is undertaken, such as the city and the country. So we made our data model publicly available. It's documented, and yeah, you can follow the link to actually look at it, and it's ready to be reused, and we already reuse it in some other cases. So we'll show you in the next slides. And we recently submitted a publication about our data model, which is currently under review. So here is just a bit of a visual of how we represent all data with the help of our data model and how it looks like. This is again just a visual of our product passport. So here, let's say we have this anonymized ICT device, and in this format of a subject, predicate, and object, so relationships between things, we represent all this data that we had specified in the ontology. And here on the side, there is a bit more specific data, such as the CPU of this device, the materials weight. We also have specific materials, such as how much steel it went to the device, so how much glass, and so on. So really, one can go into a lot of detail in representing a product passport with our ontology in a very flexible way. So, of course, to make access to this knowledge graph or database of all the product passports that we have, we built some APIs that are publicly available. So, in principle, you can just go now to the APIs and query some data about the devices and their product passports. We currently have around 129 product passports, new, refurbished, and repaired laptops and data servers. These are brands that were commonly used in the Netherlands, in the companies and partners in our project. So yeah, we basically specify different APIs through which you can get the product passports. So now a bit more on the dynamic side of things, on the application of these product passports. So within the RePlanIT project, we looked into predictive maintenance, so machine learning approach that can be used to detect failures. When we saw this as an opportunity to see if actually our model can be used for this application. So what we wanted to do, and some of the things that we did, so we looked into predictive maintenance that can help extend the lifetime of an ICT device. So for example, based on the energy usage, when a device is most likely to fail, to overheat, and so on. Another thing we were interested in is to use machine learning to predict or recommend circular processes that are most suitable for specific devices at specific time. So for example, if we have a device, a laptop, what circular process, when and why we should apply to prevent its failure and to extend its lifetime. And of course, we also wanted to really just understand the specific data that we need to actually build a machine learning model that is useful, reliable, and of course, that helps to predict the most optimal circular recommendation for a device. So in this project, we had several data sets. I will just give you an example of one of the data sets that was provided to us from our project partners. It focused on data servers and their performance. So we had this data set from one data center, around 140 data servers, and data on performance of each server was recorded every 15 minutes over 3 months. So when I say performance, I mean, information about the number of virtual machines that are running on each data server, the CPU, the memory utilization, energy consumption, different errors that are encountered, and so on. And here's just visual of our process workflow, I will not go into detail, but what we do basically with the data set is first we analyze it, we look at the distributions of energy over time, then we basically combine this data set with our ontology. So we structure the data and transform it into a knowledge graph. And this is basically in step 3, our digital product passport, which we, of course, later on utilize for machine learning. And on the machine learning side, currently we explored several types of machine learning, supervised and unsupervised. So linear regression and principal component analysis on the unsupervised side. What we found out, so just some findings that I wanted to share with you. For this data set that we had, we figured that on average, most of the servers failed around the 60th or 62nd day of their when they were run. So maybe it would be good, as a recommendation that our partners, let's say, every 60 days, they have a look at the performance of their servers, and if they notice something, maybe they can take an action. Most failures within this data set for our data servers happened on Sundays and least on Thursdays. So this is also something to explore. Depends maybe what the strategy of the companies to deal with different failures at different times during the week. For most of the servers, we noticed that they are actually underutilized in terms of CPU and memory usage. They're usually utilized around 40 to 50%, but not more. So there is a big portion of power in the server that's just there and it's idle. We did this analysis with the help of several KPIs that were provided from experts within the project. We also calculated different idle coefficients for our servers. As expected, the highest contribution to a server's energy consumption was the CPU, the memory, and the number of the virtual machines that were running. On the machine learning side, some of the results that we got, so we ran a linear regression model actually to see if energy consumption will change in the future to predict the energy consumption trend, so to say. And for this specific data set, what we noticed is that actually, yes, there was a trend of a rising energy consumption. Currently, we're looking into why exactly that is. As you know, machine learning is a bit of a black box, so it's a bit challenging to really understand the reasoning behind it. However, with the second data set that we got from another partner within the project, machine learning did not show any rising energy consumption. Indeed, it showed that energy consumption in the future will stay the same. So now we are basically waiting a bit to see if these predictions are true. We also run unsupervised machine learning, which basically does not take any input from humans, but tries to understand data by itself. And what it found out is the data that we recorded and we used was actually quite useful, and we were not to get rid of any data types, so to say. Actually, we need even more types of data to have better predictions. So as a more of a conclusion, I would say from this experience is that data diversity and quality are quite important for machine learning, especially for very dynamic use cases and dynamic data. And of course, we need data on failures in laptops if we really want to predict failures. So machine learning can learn from past experience and past context of the failures. Some lessons learned overall that I wanted to share with you from our work on using knowledge graphs, ontologies, and machine learning for building product passports and having more sustainable ICT in general. So on the data side, we learned that, yes, data availability is really important. Of course, many companies have data that they're willing to share, but is this data actually useful for the use case? Yes, in some cases, a lot of data that's not useful or is not diverse is recorded, so that poses a challenge. Also, there are different restrictions sometimes to sharing data between companies, and especially with product passports, which comprise of so much data from different entities, from materials and manufacturing of the devices through usage from end users, companies that provide the laptops. So there are a lot of silos that need to be interconnected and bridged together. And there, on the way, we noticed there are quite a lot of privacy and security issues with sharing such data. So yeah, maybe in the future it would be really important to think about this and how to make data more accessible and available. Data interpretation, of course, the format in which data is provided is quite important, the context and the meaning of it. So in our case, we used our ontology, which provided the semantics, the context of everything. So it made everything more interpretable by both humans and machines. Data quality, of course, is quite important, especially for machine learning. Sometimes, we need to record data maybe for longer periods of times, especially for machine learning. In our use case, we had data for 3 months, and as a conclusion, we figured that this was not enough because there were not enough errors that occurred in a laptop during those 3 months. So in this case, maybe several years of data might be needed to actually build a model that can be reliable. On the ontology side, of course, availability, again, it's quite important to make your standardized product passport model open, accessible, and also documented so other people can reuse it. And this will also help to go further into standardization and wider adoption. Ontology maintenance is a common, I would say, challenge within at least the semantic web community, but also I believe in many organizations, in any use case, as the regulation progresses, we also need to think of how we reflect this in our data model, in our standards, and to update if needed. Ontology reuse and alignment are commonly used good practices. In our survey that we did in the beginning of the project, we saw that not many of the ontologies actually follow this principle, which results in every project creating their own ontology, and this is not very sustainable in long term. So it's good to really think of what can we reuse in terms of technology, how can we align different technologies, so we are also more sustainable in this. And knowledge graphs, we utilize them in our project, but they're still quite an innovative solution, so to say. So in our project, we needed to provide, for example, APIs as a way to communicate our data and ease the access to it through our partners that were not so familiar with this data infrastructure. And a bit more on the human side, and what we found out, some of my colleagues' findings, that contractual obligations matter quite a lot when it comes to data sharing and exchange for building digital product passports. There are different restrictions, regulations of what can be shared. Measuring the sustainability of an ICT device is also quite challenging. It can be quite significantly different between different organizations and people. And this is also related to the human perception of sustainability in general and behavior towards sustainability of devices. And if you want to know more about this, my colleague conducted an extensive survey with representatives from different organizations here in the Netherlands, and she shares in her paper more insights on the human side of this. So what can we do? Some future directions, what we thought within the project as a summary. For our RePlanIT ontology, reuse and extension for other ICT devices is something that we're currently looking into. ICT devices it's quite a vast collection of things, not only laptops and data servers, we also have smartphones, we have tablets. So in principle, we can extend our data model for these devices. We already did some work actually on reusing our ontology to align it with the federated data model and the Catena-X ontologies for batteries. So we basically showed that we can connect and align ontologies from different data spaces and data domains to aid circular economy monitoring over them. And we are currently looking also into solar panels and exploring ways of which we can reuse our data model for them. Of course, it would be good to think about a more standardized ontology for digital product passports, at least in the ICT domain. We are discussing now collaboration with the NCDD group on digital product passports, how this can be realized. And we are collaborating on the Surpass2 project with more than 10 European partners on actually making this happen as well, and exploring digital product passports for different devices and different domains, from textiles to ICT and so on. And last but not least, what would be good to maybe think about is or to investigate is not only AI for sustainability and helping, let's say, predictive maintenance, but also the sustainability of AI itself. There's a cost associated with running and maintaining AI and machine learning models, of course, a cost of storing data in different data servers. And of course, AI is quite famous now, let's say. Everyone is using it, but it's also important maybe to really think if you really need AI for specific tasks, because some tasks are more simple and maybe they don't even require AI as a solution. Yeah. So this is maybe something to think about in the future. And now, thank you for your attention, and I pass on to my colleague Menno. Yeah.
Yeah, as we have two Mennos, just to make sure.
Both online.
And I was just I wanted to share that based on this ontology, there were prototypes developed. One for servers, which is basically has been developed further into what Menno is going to explain, but also for laptops. And for laptops, Circular IT Group has actually recently put a simplified version of that prototype online. So I'll share a link in the chat that you can check that out. And then I give the word to the other Menno.
Yeah, thank you very much, Menno. So actually what Anelia described is like a new era we are entering, where we can follow everything of the materials we are using in products, and having like a full control, full accountability of the usage and also of its effects. But please let me just take you a little bit back in time, when there was a time of more abundance. I don't know if you remember this feeling when you just opened up the tap water, water ran out, and you didn't feel that it costs money. You didn't feel guilty that this might have been a waste. And also for the heating of your house. There was a time when we did not think about it, right? About the energy costs of our house, because it was just so cheap. And we didn't have that guilt also that we were wasting energy maybe, or thinking about the source of this energy. And also there was a time when we were using data, and we didn't think of the consequence of using this data, because this data also consumes a lot of energy. And like Anelia said, are you really needing this data, or are you really needing this AI? Well, this time is changing, and it's changing for the good. We all are aware of that. I'm Menno van Leeuwen. I'm an innovation and sustainability consultant, and I will guide you through how we came from RePlanIT towards our venture Zirrow, where I will talk about more. And I will just touch upon some of the projects I'm involved in. Currently working also for Impact Institute. They are known for true price, so that's why the true price of data is in the headline. I will get back to that. And I'm also the co-founder of Zirrow, which was founded by the partner who was in RePlanIT, we call it, and Bliss Digital. So let me give you a little bit flavor of how we went from RePlanIT to later on Zirrow. And I think Joppe really stated this on the RePlanIT website quite strongly. So it is about this mental shift that we all know in the industry, but now also the public, that it's not a completely virtual world if you have data centers. And there is a strong correlation also via energy usage, water usage, also in the carbon footprint. As we call it, as a partner, during this project, the focus was on the server usage and getting lots of data in about servers. And we learned a lot about how servers are not used efficiently at this very moment and are creating avoidable energy waste. So this is the business we got into. And just to give you a conceptual picture of why this is so relevant and getting more and more relevant, that has to do with the cost side of it. So when energy is really cheap, and it has been cheap, and for heavy users it is still very cheap, you tend to only look at the financial costs of it. And then, well, you can worry about it, but it doesn't feel as painful in your wallet. But of course, there are many other cost factors which are hidden, which are not calculated in this price yet, which have a negative effect. For instance, in the IT circular part, the use of materials, that has also a cost factor. So you can take that into account. The water usage for the cooling, that has a negative potential effect. Even the end usage of these kinds of products, so what value it gives, some of the digital usage creates addiction, creates less health. All those factors are not really in the model yet, but you see an increasing concern of people to really look at the true costs of when you're using products like data-driven products. But also taking into account of what is the true value. So if you use it for the good, there's a balance. I will zoom into the topic, of course, that data usage creates a lot of energy usage, which has a correlation to a carbon footprint we are now creating. So zooming into that, the problem already is quite big. So on a global scale, already of all the energy which is available, 3% is used for data usage. In Europe, it is 4%. And if you take a look at where this is going to, and of course here the AI boom is really igniting this. It could even turn out to be much worse. So more than 20% of all energy availability is used for data, one way or the other. And this is quite alarming. This is making everybody see the data center industry more like the coal-fired industry. And this is an image that you have to really manage better than we're doing right now. And of course, it's needed to really try to improve also having a more energy efficient way of working. Why is that needed? Of course, the reasoning why a carbon footprint we have is a risk is that it hits our planetary boundaries. So we're feeling the effects in our environmental living conditions, e.g. Extreme weather effects. But also on the side just of supply, having enough available energy for data processing. Of course, there in the Netherlands especially, we're feeling already the problem of net congestions. So there is a problem factor as well. And also when you are increasing the volumes of data and of cloud usage, you also have the cost factor. So we really love the positive side of digitization and the positive effects also on sustainability. There's an upside, but the downside for many companies, many heavy data users now, is also that their cloud spend gets high or even out of control. And then last but not least, you also have a pressure from the society, from legislation side, that you have to really report and reduce the energy usage as heavy energy using companies. And you have the Energy Efficiency Directive, which is already tackling on the biggest energy users. But now also from this year and next year on, many companies, mid-sized companies, will have to report on all their environmental and social footprints they have. the Corporate and Sustainability Reporting Directive. And this will make it more transparent for everyone. And just as I won't lecture you, you can do a lecture later on if you're interested on CSRD, so this directive. But just look at which topics companies will have to report on, and many companies will have to report on their role in climate change adaptation, mitigation, but also the energy usage. And companies who are reporting, all the mid-sized companies and large companies already this year, they will have to report on their energy usage, on the greenhouse gas correlation to it. They have to do it from their own operations, but also from the total mix, so the source, whether it's green or not, but also scope 1, scope 2, scope 3 for high climate industries. And data center industry is a high climate industry. So we have to measure and share transparently much more of the effects of the data we're using. And already you see some big companies being accountable on this, publishing, like the big data user Vodafone Ziggo, and putting it in an integrated report. So this is what CSRD does. It puts all the financial and the non-financial information in one complete report. And also there you see targets of Vodafone Ziggo on their carbon footprint emission affected by their data usage on scope 1, 2, and 3. So also on all the data processes they even outsourced. And you see many companies setting goals and targets. So just highlighting KPN as an example, they want to become 100% sustainable in 2030. Those are nice ambitions because it's also needed to be ambitious, to really keep everything manageable, livable. But of course, this triggers the question, if this data usage keeps on growing, like the predictions are, how to really become 100% sustainable. And the answer is we need real innovation on that part. So it is an opportunity era for many companies who are innovative and could help on the green coding, virtualization techniques, smart cooling, residual or circular IT concepts will be very needed. The consumer side on storing behavior, and also being more smart on how you balance performance and power. And this is where our venture, ignited by RePlanIT, got started. It's called Zirrow, and we're zooming into how to balance smart power and performance. Well, the problem I think I already stated is this growth of data, energy correlation, and the availability in an accountable way of that. But there is also a problem why this is not really efficient yet, because you could assume, why aren't we efficient? So just to take you through the logic of why there is a lot of avoidable loss, energy waste, is that in the center, you see these servers, there's central processing units are focused on performance, always uptime, no latency. But when there is no work, they go down and they can go in idle state. And then they just need a really small amount of the energy. So that is a good thing. However, there are settings you can control, settings that are standard. The two biggest categories are the high performance mode, which is like optimal performance power, always on. It's like the heating in your house is always on. But you also have a balance mode where you balance this, for instance, on the workloads you predict. And the bad news is that in many cases, the high performance is the standard way servers are set. And this is maybe good for the power, but it is, of course, creating much unnecessary usage of the server, of the energy effects, of the carbon footprint, and we see up to 40% potential energy waste. So now you're thinking, okay, Menno, if this is the case, we can just adapt the settings to balance mode. Let's just run to our own or co-located data centers and just adjust these settings. I would advise you to do that, but of course this is easier said than done, because there is a system change needed. So at the traditional setting, if you have all your data in an external data center, the data center just runs your like a hotel, runs your service, either hosted via another party, and they just pass the bill on to the end customer of the energy usage. Even they put a little margin on. So there's a false incentive in the setting to really reduce energy usage in data centers. And there are also some other hurdles we have to take, is that nobody is really waiting for latency or disruptions. So there is a cultural way, if it's on high performance, then we are safe. It's a safe choice. We don't have any problems with KPIs. And that actually is not the case. Maybe for mission critical applications that is the case, but that's not an excuse to put all your other servers for other application works also on this high performance. For companies to really get into action, then it's also a hurdle. You have to have this overview. So if you change settings, are you really comfortable that this doesn't change your performance? Well, this is where Zirrow steps in. So we have a solution for that to really become future-proof, and just explaining this in 3 simple steps. So we do a scan of companies who have high data usage, either their own data centers or in the cloud, and we just measure the energy usage that this created. We measure the workloads that they have been running. We measure the actual needed performance, and then you see a gap. You see a gap. What percentage is like overly energized, not needed, and this we can put in a coefficient. And then, of course, our advice is to change these settings. But of course, the worry is that the performance has to be remained optimal. So in a period of time, we can give you these insights that when you change these settings, you still have the insight and you have the output that your performance is still optimal. And this gives confidence, of course, that you can change settings. You don't need the high performance 24/7, 7 days a week. But also it creates in this period efficiency effects, because you will see that in this period you also save energy, you save energy costs, you save carbon footprint effects. So and you save, of course, also capacity. So it's the way to be much more efficient. And as a third step, we are running now several projects with big companies in the financial industry, in the hospital industry, and then we follow these effects for them, but we also certify the delta which has been created. So the avoidable energy waste which have been created by adapting these settings, you can put into a contract. It's certified, and also this is input, for instance, for this corporate sustainability reporting directive I just explained to you. And then the accountant who has to give the insurance on it, he is secured that you took your measures. At the end of the day, we give you a dashboard with full control over all these factors. So you see the cost reductions, the energy waste improvements you made, but also you keep on having a view on the optimal performance. So for heavy data users, I already mentioned some examples. This is the way to go. It's not only an environmental sustainability case, but it's also a business case. And in most of the projects we are running now, we indeed see that the savings are in the 10, 20 to 30 to 40% cases. So it is way significant. And this is the way we really see this future towards balancing all this digitization needs more in the room we have as a planet, and to keep also on the sustainability side, keep it accountable, and ultimately have no energy waste at all. So thank you very much. This was the teaser we gave to you about Zirrow, about the link with RePlanIT. If this triggers, of course, questions, please contact us. And of course, we're very curious after having heard this presentation. Do you think you are using your data quite efficiently already? Where is your avoidable waste? And we'll help you to measure it. Thank you very much.
Thank you, Menno. Thank you, other Menno. Thank you, Anelia, for this very interesting presentation. We run a tiny little bit longer than expected. We have 6 minutes left for questions and discussion. So please, if anyone has already any questions, hands can be raised. We'll be happy to answer. I see a hand of Isaac. Isaac.
Yeah, hello, can you hear me?
Yeah, we can hear you.
Hi, hello, thank you for your presentation. It was very nice to listen to you, and very interesting topics. Also, right now I'm working also with ICTs in rural areas. I see, I mean, of course, there are some similarities and some differences, but I wonder, with the last presentation, how can you say is the impact for the end users? Because, I mean, for example, me as Isaac, maybe not working as TNO, but Isaac as a user of iPhone, or I don't know, whatever computer, how does the data, a huge data use, impacts me, and what are the motives behind my reduction of data in my daily life? That question is yes for me, but also when in my work, I would also like to address farmers, and then they will also ask me that question: hey, why should they reduce their data when we're trying to digitalize the rural communities, right? Maybe it was a very different question, or a very large question. Do you think you can help me answer that, or how can you address that question?
Yeah, thank you for your question. So I think everyone who sees this presentation could correlate it to himself. So we're all data users, of course, with our own smartphones. And I think just realizing that there is a limit, there is no abundance, and there is a cost factor when you store lots of data. You don't clean it up yourself. You don't use smart file sharing if it's available. That is already like one step where you can improve, reducing energy costs and the carbon footprint, which is related. And then when you take a look at different industries, I think for all industries there is just easy advantage to take, so easy sustainability effects to create. High data using sectors especially, so these are the examples we're working on right now, but also for industries like a farming industry who working on who have like their own operations on IT. It's just like a very easy way to reduce some of the energy effects they have, because they're running IT. It will not be their biggest portion of the total of their footprint, especially in their value chain, because that's of course the land use or animal use they have. But it is something which is very actionable. So we really see this as everybody can chip in, and you can make it concrete that it saves energy. It's not needed. It saves money. It saves negative effects, and you can make it measurable.
Okay. Yeah. True. Yeah. You're right. Yeah. True. Maybe it's not the biggest concern. True. But yeah, definitely consider it at future-proof goals, as you said. Yeah, definitely. Thank you very much for that.
Thank you for your question. I saw one more question. Arina, I see you put your hand down, but if you want, we have 2 minutes left in this meeting. I would say we can have room for one more question. And then, of course, if any further questions later on, we can always contact the speakers of today.
Thank you. I liked both the presentations very much, and I wanted to ask if there are already results by Anelia Kurteva about the use of smartphones, because that's my first question.
Yeah, so currently on the project, we focus mainly on laptops and data servers, but of course, smartphones are quite interesting as a use case, and they also store a lot of personal data, so there might be even more challenges to privacy and security there when it comes to getting data for product passports. But yeah, I think in the future, this will be also another important use case that we should look and explore.
Does it answer your questions? Yeah, nice. You said 2 questions, but was this what you wanted to write? Thank you. Thank you very much. We're beautifully made it within the hour. I learned a lot myself, so thanks for that also. I think it was really, really interesting. And just quickly in the chat, I share with you the link to the next one is about AI on a sustainable way. So as it has been mentioned already today, this is by Alex de Vries from VU Amsterdam, also in English, also open to a wider audience in different languages. So for anyone interested, it's on September 10th. And yeah, little promotion for our webinar series. I'm really liking this. It's a very nice way to share. And this will be later shared on our website. So for anyone that couldn't watch, can see it later. Thank you all. I wish you a very nice day. And hopefully see you next time.
Thank you very much.
Thank you.